given point in time. That's where rights and prior art come in all of the time. And that turned out to be important later on. Now, this history extends all the way forward into the present. And I got back involved about here because I was worried that this wouldn't continue. That all the wonderful work that was being done at Berkeley and had been done over the years might end up on a VAX. There were carton VAXs out the door at the time for the gold in the contacts. They would go and take the machines out, strip the contacts of the board, and gain like $5 or $10 worth of gold out of a $40,000 board all of the time. And the other machine was a CCI Power 632, which was a byte-swapped VAX. It wasn't going to live very much longer beyond that either. That was the original reason for doing it. It changed as time went on. That was the mission. Move BSD to a 386. It's documented on the web as 386 BSD, a modest proposal, which was circulated at the time. It used a community development model, not unlike the Sun Java model, although not nearly as particular about certain things. This work was done largely at and in Berkeley's offices. And the community model allowed a large, I see I've got another, a large number of people access to a limited subset of source. At that time, Berkeley hadn't made the commitment to go and provide a open development version of its software. But it was this was the genesis of that project. It was documented in DDJ, and it was an active account as it occurred. So if you go back and look at those articles, you've got to realize that as one article went out, we were doing these things in time. Now, this turned out to be very helpful for backtracking later on by the legal eagles, because they could see the emails. Okay, there was a record of the emails. They could see everything that was going on with this project. They could see the origins of it. They could see the footnotes. They could even see how things changed in a galley prior to publication. And so if one was going to be doing anything other than a straightforward job, you couldn't do it and keep up with the rate of release and publishing. And this reminded me very much of what was talked about by a professor who told me that if I was going to be an academic, I have to learn to publish, or I wouldn't be able to keep in the field, keep doing things. People wouldn't take me as credible. So by publishing, that turned out to be one of the strongest ways of communicating the intent of what we were doing and the point of what this was about. There was no hiding. There's no way of playing a game in there. We were quite literally writing the articles. In one case, I wrote an article 5 minutes before deadline at the office and took it with a floppy disk and put it into their production machine. And then they finished that part of the article. It even has spelling errors in it, by the way, because I didn't get a chance to spell check it. That's how timely it was. And you know what was also interesting about this was that people were getting back to us and saying, you made a mistake in this line of code. And they were doing that in real time, you know, like a month delayed. It would show up in the letters or in an email. And that meant that the whole process of how this was doing was in effect being vetted continuously. People were proposing better algorithms all of the time, and some of them actually got adopted in subsequent articles. The early year, this is the code review process to try to make sure that we were doing an honest, good job of our development code. We looked at all of the contributions that we got in, and we did the first scan that you do, everybody does. You look at the comments, the file names, the code structure. Is this a genuine article? Generally, you can tell if somebody's done a good job and had a background in this area, they make a good program. You know, programmers, developers can see good code. They can also see the fingerprints in the code to know what it is that they're getting. They don't want anybody else's stuff. They want the real, genuine article. The second tier of this is that of algorithms. Algorithms, as you know, can be classified very nicely. And you do this anyways when you look at the performance of an algorithm. You want to see if it's order of n squared, if it's linear, if it's a power function or exponential. And especially when you're in an operating system, every little bit of that machine matters to you. One of the things that was constantly changing was the memory allocation policies. The memory allocation policies, frequently we would find that the system would be starving for memory because it had fragmented memory in a peculiar way. And the early versions of 386 BSD are, you can tell it got worse, it got better, it got worse, it got better, and it was all around how to make sure that you were coalescing memory appropriately and not inducing new errors. And that was an example of an algorithm that went through a lot of change. So by classifying things, you could tell where things would come from and who was responsible for them. Because there'd be certain people who follow the Knuth model for certain algorithms, or would innovate new ones, or there'd be the latest algorithm that would be in a book, like Patricia trees or something at the time. And this was how you knew a lot of what was being contributed to you. You could also tell when somebody was being lazy and not doing as good a job as they could. And sometimes you have to send back to them something that's, they wouldn't really greet this with great joy, but can't you use this algorithm and not that algorithm on it? Because we know this one works better for these reasons. If you want to go run the numbers yourself and do a paper, that's the kind of thing that I'm talking about here. That's the match with known targets. The third tier is heritage. Heritage is we're about to go and put this stuff in. We're about to commit here, and we're not going back on this. So we need to know what the heritage is of this code and this developer. What else has he done? Has he done other things like this before? What was the experience with those pieces of code? Were they used in somebody else's product? Were they, is this a spin-off of some other group or some other venture? There's some code in 386 BSD, in fact all of the BSDs, which came originally from a dead company. I had to go back and check to see that the company truly was dead and where the rights were transferred to. I spent 20 hours once with a lawyer dealing with that very issue and documenting it to everybody's satisfaction. Not an easy thing to do. The other issues were progression. People go and they design something. You can tell they go from one algorithm to the next algorithm to the next. They actually run the regression tests, and from that you know that this person is doing their job and is a true soul to what it is that they've committed to. Those are the things you start looking for. Now you're about ready to go and make and accept something here. Now you've got your last hurdle that we had to do. And that was dependency on hidden aspects. What if this guy doesn't know that there is something that he's using that is embedded there? Okay. There are some silly patents out there that you want to know about. A lot of times people aren't aware of them, but that comes from looking at similar protected objects and understanding where things manage to lie. Now, prior to Net 2's release, which is what 386 BSD was based on, it's not based on 4.4 BSD like the other ones. It's based actually on Net 2. And that too was litigated over, but 386 BSD was never. And the reason why? A very simple reason. When we released 386 BSD, we didn't release everything that was on the Net2 tag. Because there was a big disagreement here. There was a lot of work at Berkeley on matching against protected code database. This does not get talked about very much. I think this probably is the first time this has ever been mentioned. There was databases at Berkeley on source, so complete copies of source, and a way of using it as a database. And so that was a way of making sure that nothing unfortunate escaped. That was the idea behind it. Yes? No, I'm sorry, I thought you switched sorry. It also, by the way, didn't only have Unix, even very old versions of Unix. One of the interesting things, by the way, is that we found that pieces of old Unix were showing up in new Unix from time to time. And we could never figure out where that was happening. But during the process of putting together the Berkeley release, there were a number of issues like this that came up on a continuing basis. And you would have them reintroduced. So you'd have to rerun these database scans from time to time. And some of this also, you'd see pieces of other people's systems show up in that had nothing to do with Unix whatsoever. So you'd have to scan against them as well. Very few people would have such a database. You would have to have licenses to have such a database. They had the licenses. That was one of the things about being in an institution. It could check for things and could make an assertive claim that one tried to track down even the unfortunate ways in which things could be accidentally pulled back in. And that's one of the things that Berkeley did. It was really good, really first rate, I thought. But one of the things that I found took issue with was preserving some of what I would call the obsolete design components. And those were kept, things like CList, BMAP, CDAV switch, for example. These are things that were kept largely for 30-year-old disk drives, drivers and tape drivers and things like that nobody wanted to bother to rewrite. And I couldn't really understand why anybody would want those things, because you couldn't have them on a 386 in the first place. You couldn't have them in any modern machine looking forward. So it might be useful to somebody, I suppose, who's trying to make a living supporting an obsolete machine, but that doesn't sound to me like a very logical thing to have at any given point in time. That turned out to be an issue later on. Those things weren't actually the long-term 386 BSD goals.